All right. Okay. I think we're going now.
All right.
All right. Yes. Okay. Sorry about that stunted intro. As previously, there will be a sort of 20 to 30 second delay between what we're saying and what is happening in the chat and on YouTube. So sorry about that. Just to get started, what a crazy couple of weeks. Like, wow. So much is happening. It's happening so fast. So many people are involved. Stunted intro. As previously, there will be a sort of... Who am I hearing here?
Someone must have
Whose
their
speaker is that?
YouTube window. Oh, it might have been me. Anyway, make sure everyone mutes their YouTube window if you're one of us three.
What a crazy... Is everyone muted? Okay, sorry about this, everyone. I'm muted. Here I go. Okay, cool. All right, that's better. Okay, yeah. It's been amazing to see just the feverish pitch that development has been happening, the amount of people who have got involved in just the last few weeks. So much so that I've kind of had to like reevaluate sort of to bring in faster a proper kind of communications, sort of like a way of explaining to the community and everybody actually how the community can connect better with the developers and how the community of users can understand what's going on in the development process and how best everyone can talk. So I've started strategizing this a little wee bit with Jamie and Aria, and I've got a few ideas, and just give us a couple of weeks to sort of just try to iron out that workflow a little wee bit because it's kind of everything's happening quite a bit faster than anticipated. So anyway, for today's chat, I'm pretty much just going to cut straight over to Rohan. We've got a whole bunch of questions we've been asked in advance, and so Rohan will share his screen and sort of talk through those questions. And then just like the previous Q&A, after that, we'll cut to the YouTube chat and see if anyone's got any questions there. If anyone has any specific questions for Jamie, maybe think about asking them soon. I think it's around 3 or 4 a.m. in the morning where she is, so she might bail at any time, I imagine, which is totally fair enough. And I think Aria's in the chat as well, and it's about the same time where they are as well. So yes, anyway, I'll switch over to Rohan, and if anyone has any questions to Aria or Jamie, put them in the YouTube chat now. Otherwise, Rohan can cut loose.
All right. Hi, everyone. Thanks for all the awesome questions and all the amazing work. As Ian said, it's really awesome to see what's going on in the open source community. So yeah, we've had a bunch of questions come through. I'll just sort of start going through them in sort of no particular order, but I've got a bunch of code files loaded up I'll just share my screen now and we can talk through some of the code. Here we go. So, right, this doesn't relate to the code on the screen yet, but we had a question about the bootloader source code and whether we'd share that. Me and Ian are talking about it. That could very well be a possibility. Could be a possibility in the future, but we'll come back to that at some later point. So someone was asking about.
I want to quickly. Sorry to interrupt. Do you want
to
mention about that bootloader issue we were talking about last week, and just maybe explain that we have it now on the wiki, on the Git, and yeah.
So what came up during last week's session, we talked about or were sort of reminded of the fact that some of the older bootloaders on older Deluges had sort of a bug where if you tried to load the wrong firmware file and it was either 0 bytes or way too big, it could corrupt the bootloader itself. So anyway, we've got a document on the GitHub wiki now explaining what you can do about that and how you can update your bootloader. So have a look at that if you're worried about that. The chance of it actually going wrong for anyone is pretty small, but the document on the wiki has some more details. Okay, so first question. How parameter values between cloned clips, how do they work? So, and this sort of relates to another question that is later on the list. I'll talk a little bit about param managers. So I've just loaded this up on my screen there. Hopefully you can see it's parammanager.cpp. A param manager stores the params, which broadly they're the ones that can be controlled with the gold knobs and are MIDI learnable, and the ones they are also the ones which can have different different values, different parameter settings between different clips, and it also handles parameter automation. Yeah, have a look in Param Manager. Within Param Manager, it can store essentially several param collections. I realize this is going to get pretty complicated pretty fast, so I'll just sort of skim over it. Within Param Manager, there's param collections, of which there are several different types. This is handled with C++ polymorphism, so it's an abstract class param collection. But below that, there are several different types, including there's one for MIDI parameters, which is just for MIDI clips on the Deluge to store MIDI CCs and that sort of thing to be able to output. There's also there's one for storing the information about patch cables themselves, which is the sort of internal language I've used for when a source is patched to a parameter within the synth engine. So there's a param collection for that. I think it's called patch cable set. Here it is referenced here in this document. Basically, within this whole system, this is for parameters that have their values sort of changeable between different clips and have their values and automation sort of managed in this sort of cohesive, homogeneous way within the system, as opposed to the parameters which where you cannot have different values between clips. Now I'm tripping over myself in my head a little bit. Basically, I'll load up the file for clip. I'm losing myself a little bit here. I'm sorry, it's a little while since I've dealt with that particular bit of code. I'm going to move on, but some similar sorts of questions relating to parameters and param managers and stuff will come up a little bit later in the session. Another question: how is Stutter implemented? I loaded up the file for that earlier, but it seems to have closed itself on me. So that is in mod controllable audio. Mod controllable and mod controllable audio are sort of base classes for a lot of stuff beneath it, including sound and kit. The name is a little bit of a relic. The name comes from the fact that you can control aspects of it with the mod knobs or the gold encoders. But anyway, yeah, think of it as sort of a base class. So process stutter is a function here in mod controllable audio. It does all the stutter stuff in really not too many lines of code, really only about 2 screens. I guess it calls some other functions. Again, very long time since I've dealt with this bit of code, but basically, while you're holding down before you hold down the stutter knob. No, it's when you first hold down the stutter knob, it starts recording into a buffer. That's when the stuttering status is recording here. So when you're just using it, you might not so much think about whether there's 2 different states, recording or playing. That's sort of going on in the background. You think of just pushing it down and then it starts repeating. But actually, when you've pushed it down for that set stutter rate, like it's going to be stuttering every half second or something, although it's often expressed in quarter note or eighth notes, etc. But it'll spend that first half-second recording into a buffer here, and then it'll instantly change to playing back. And so it will have recorded into the buffer at just 44.1 kilohertz. I think actually it might, similar to a delay, it seems to have a fancy thing that I wrote a long time ago, so that if you change the stutter rate while it's recording, it will go and write to the buffer at a different speed than 44 kilohertz. That's sort of a fun side note, but definitely when it's playing back, as you know, of course, as the whole point of Stutter is, you can turn the knob and the read rate changes, and that's this resampling code here. So that's Stutter basically. Yeah, check it out in modcontrollable.cpp. Let's have a look at another question. Parameters that can't be mapped to Midi or to the gold knobs. Is there a technical reason why that can't be done or shouldn't be done? Essentially, no. There's no real reason. I mean, yeah, no reason that you can't do it or try it. The question references the saturation setting. The reason I never mapped that to a sort of a continuous MIDI CC or gold knob thing is because the way saturation works, as many people will know, especially say guitarists who play with distortion a lot, saturation's it's a tricky one because you can't just turn up the saturation amount and have it sound more saturated at the same level. Saturation is when you turn the sound up, it gets louder and louder and louder until it starts sort of peaking out at the top. So depending how you've got it set up, the level might come across very, very differently depending how much saturation. The way I've got it set up, it tries to sort of normalize that by having it so that basically it's that the headroom comes down and down a bit to a certain point, and then the signal sort of comes up more and more under that as you turn the knob more. And this was sort of implemented in a very stepped way, and that's why that's why that code is that way. I think also that's pretty much the reason. Other things, I never got as far as being able to map MIDI CCs to like a parameter, like the sort of discrete value parameters, like say wave shape, which is saw, square, etc. That could totally be done. It was just a feature that was never implemented. But yeah, you could set it so that for a MIDI CC, like if it's like an LFO shape, say, that has like 4 or 5 different options, you could split the CCs up into percentiles or something where the bottom fifth goes to one wave shape, etc. So yeah, no reason you couldn't do that. Next question. Okay, here's a nice in-depth one, and I like those. How does the drive effect on the low pass filter work? So hopefully everyone can see my screen still. So the drive effect, essentially it's just saturation, and very simple saturation as well, tan H saturation. It's actually, it's right here. So, but there's also oversampling that takes place to minimize aliasing. This code I wrote a very long time ago, but I was really pleased with how it turned out. So this is, we're in filterset.cpp. Render LPF long is the function here. There are a bunch of variations, and in some cases, duplicated code, which I never like doing, but this is for efficiency. Basically, there are some cases where having a function to call separately on each sample is a good idea, and other cases where having a function to process large blocks, like a whole window of samples, all in one go makes more sense. There's not too much code duplication, but I don't quite remember, but I'm sure there was a very good reason for the amount that there was. So I think some of the stuff that I'm about to talk about might show up in 2 different functions in this file. Anyway, so the drive filter. So this is still within render LPF long. in filterset.cpp. Here's the there's a very good comment here that I wrote explaining how it works. Basically, so it oversamples by a factor of 2, and does the oversampling in a crude way that works pretty well. Really, you can't really hear much aliasing, of course, the idea of doing sort of simple linear interpolation is to avoid excessive CPU usage and stuff, and so it's pretty efficient. It doesn't take too much more power than the non-drive filter. So basically, what's happening here? This is, I think this gets called, yeah, this gets called for this block here, this while loop, this do while loop gets called for each discrete sample of audio, and if what's happening here, if we're oversampling, then it does it twice basically. I've lost track of the bit of code that does it twice. Maybe I'll refer less to the code on screen and just talk through how it does. So for the oversampling code, it pretty much just duplicates out the values. So yeah, the oversampling is really crude. I think it actually, does it not linear interpolate them even, and does it just put an extra 0? Which is what I wrote in this comment here. Basically, these comments here will probably explain it better than I'm doing now. Yeah, just take every second sample with no anti-aliasing filter. Works fine because the ladder LPF filter takes care a lot of those high harmonics. So that's how it works. Obviously, it's not perfectly anti-aliased, but it works well enough and is very efficient. And then it applies tan H saturation, and then also it downsamples just with linear interpolation again. And tan H distortion or saturation itself, that's just a mathematical function which is widely used in a lot of DSP or effects. Yeah, it's implemented here as a lookup table, for which, if you haven't seen this yet in the code base, and if it's something that interests you, this is the function for interpolating between values in a lookup table. It's sort of nice and short and compact. This is in functions.h, where that interpolation function is, if that interests you. And the tan H table here, this is yeah, nice, simple, small, I think it's 256 or 128 values of tan H. As a side note, there's another tan H table here for the saturation effect, which we talked about briefly earlier. And I know this isn't the question someone was specifically asking about that, but there's actually a 2D tan H table, which is really big as well. This is it here. So we're in lookuptables.cpp, which is where all the lookup tables that aren't too huge are. This is to help with the saturation effect, to try and minimize aliasing with it. There's a 2D tan H table where it sort of takes two sample values, like the previous sample and the current sample, uses those as 2 dimensions and finds a value, and using those reduces aliasing a little bit. It's based on a particular academic paper that describes this technique. I should put a comment in actually saying what that paper was. Of course, I wrote this back when I thought I was the only person that was going to be dealing with that code. Anyway, that's a little bit of a side note. But yeah, I think that sums up how the drive filter works. It was, yeah, tan H saturation and crude oversampling and downsampling. And the oversampling only happens if, only some of the time, only if the filter frequency is high up, and I think only if there is resonance on, because otherwise it doesn't make much of a difference. Let's just see. I've got my search window open and on a different screen, so you can't see it, but here's the bit where we decide whether we're doing the oversampling. We're in filterset config.cpp. looks like we just oversample if the resonance is beyond a certain threshold. But also if the CPU direness, which is, so if the CPU load is high, then that's oversampling might not happen. I'd forgotten about that, and that was something we've never exactly disclosed, but there you have it. That's another slight disadvantage in quality you get when the CPU gets overloaded. Okay, I think that answers that question. Let's see what we've got next. Just keeping an eye on the chat as well. If anyone has any particular comments or sort of small sub questions that I can answer quickly, please throw them in there. Okay, this should be a pretty quick one. Are there any negative effects like battery life or performance headroom associated with higher LED refresh rate for the grids and buttons? So you might have noticed there's a function where well, you can set the refresh rate. There's a sort of a secret shortcut for it that sets the refresh rate of the PIC microcontroller that just controls all the LEDs and stuff, so it will cycle through those columns faster. Basically, there's no definitely not battery life or performance. They won't be affected. Not performance because it's entirely on a separate chip. The Renesas processor doesn't even know when those updates and stepping through the columns, when that's even happening. The disadvantage is that if you turn it up too high, it starts to glitch out a bit. That's all really. And yeah, the colors get a little bit less distinct or a bit sort of more milky, and eventually it gets really glitchy. So that's pretty much the reason. You can turn it up a bit more than what the default is, which I think is value 24 or something like that, that's an arbitrary number, sort of unit. Yeah, so no real advantage. Here's a nice sort of juicy synth engine question. When it comes to modulating parameters with other parameters, so yeah, sort of synth modulation from a modulation source to a parameter, which ones are multiplicative as opposed to additive? This is a really good question, and the code goes to great lengths to implement all of this so that parameters can be modulated in ways that make sense, and which you might not sort of always have to think about as a synth user, but as a programmer, you absolutely have to. So where is it? So we're here in definitions.h, which has a lot of stuff in it, possibly too much for one file. I was just looking through this before with this question in mind, and I've added just a couple more comments just now. I mean, tiny comments, but I'll commit these shortly, but you won't see them in your code base yet. So here is a list of all the synth parameters that exist within the param manager sort of system, actually, which is I talked about that a few minutes ago. These are the sort of generic parameters which all function within the same system. So it's not any of the ones that have like a distinct number of values, like wave shape, like sine wave, square wave, saw wave. This is just the continuous parameters like filter, frequency, pulse width, levels, FM amounts, that sort of thing. So they, to reiterate, they are taken care of within param manager, and then within sort of other sub levels below that. So this is param manager.cpp you can have a look at. But back to where we were just now in definitions.h, what those parameters are is set out, and each one has a number. There are a total of 42 parameters, and they are split up into sections that delineate them in terms of things such as whether they're additively or multiplicatively combined. So let's talk through some of these. First of all, the first division is between local and global parameters. So local means just within one voice. of a synth, whereas global is for the whole synth. You can argue about whether global is an appropriate word when it's still just for one synth, and there are many other synths probably within a project, but they're sort of separated and need to be processed and thought about at different times within the execution process. So let's just talk about the local params for now. I'll just stick some extra space in there so we can, because I'm going to highlight different bits within this. So within local params, and the same sort of sub distinction happens again within global ones, but let's just talk about local ones for now. So first up, we have linear params, and the language here can be a bit confusing because the linear ones are the ones that have their modulation values multiplied together, whereas the exponential params are the ones that have their modulation values added together, which might seem really counterintuitive at first. But the reason, I think this is pretty much a universal thing, that I don't think there's a different way it could have been done. I think this is just sort of maybe it's the language I've chosen to use. I'm not quite sure. Let's talk about the exponential ones first, because there are these other sort of sub delineations like non-volume params and hybrid params, but exponential ones are nice and distinct here. So let's just talk about them. And these are things like so pitch. It's definitely an exponential one because, you know, raise the pitch an octave and the frequency doubles, etc. So there's several pitch ones in here. Also, low pass, filter frequency, and high pass. So another many of these are frequency related. Then also there's envelope related things, because that sort of makes sense to do them in an exponential way as well. Anyway, so for this sort of parameter, the way that modulation occurs is, firstly, like if it's being modulated by a couple of different things, which is pretty common, like especially for something like, say, filter frequency is often modulated by an envelope, and also something like, say, LFO, and often velocity or aftertouch. Those are probably the most common ones, but could be modulated by all kinds of things. So often you'll have multiple modulation values coming in from different modulation sources, and they need to be combined, and then that resulting value has to be applied to the actual parameter that we're modulating. So for exponential parameters, the sources coming in to modulate that parameter first get added together, not multiplied, but added. And I'll come back to that. But then once we have that combined modulation value, which is all added together, then that gets sort of applied to the parameter in an exponential way. These again are exponential parameters in that they need an exponential curve for the parameter, but the different modulation amounts or depths, or just actually current values from the modulation sources get added together. I suppose you could also do it by, for the various different modulation source values coming in, you could make each of them individually exponentially control, modify the parameter. It would probably be the same end result, but this is just to sort of save CPU and do things efficiently. They're added together, then that's given sort of an exponential curve. I won't stay on this question too much longer, but it's similar with what I've called here the non-volume params, which are also linear. I'll commit these comments soon. These ones, the modulation values coming in for multiple ones get multiplied together, but then that multiplies. Confusing myself here. For linear params, the resulting modulation value then gets sort of multiplied to the parameter like base value for these ones, which don't need as much of a logarithmic or exponential curve. So that hopefully gives a bit of an overview. A place to look for more code relating to this stuff is, I think it's Patcher. Patcher is the class, patcher.cpp. This is a class which there is an instance of patcher within each voice and also within each sound. The voice ones are for the local parameters that are per voice, and the one within the sound for global parameters. This does things like combining those modulation sources, by either adding or multiplying, depending which type of parameter, and then also the actual applying those to a parameter, combined cables, linear, that sort of thing. Cool. Let's move on. Cool. Here's another related question. Since we're talking about parameters, when one parameter is being modulated by another, what resolution is that modulation occurring at? So there's a little bit of information on this that I put in the code base introduction document, so you can refer to that if you need some more info on it later, but I'll quickly talk through it now. So audio is rendered in a window, I call it, sort of as just a certain amount of time or of samples at a time. And that can vary hugely from one sample up to 64 or more. Modulation is recalculated. Sorry, I'm just glancing at the comments because I saw there's been a couple. I just don't want to miss any important extra questions there. Modulation gets calculated, as we just talked about how it's calculated. It gets calculated at the start of each window. That's sort of the resolution, you could say, but then there's also linear interpolation within that window for most parameter types. Well, quite a lot of them. For things like volume or level, and also for things like FM amounts, if the value sort of suddenly stepped up or down as we change from one window to the next, you'd get what's it called? Zipper noise, I think it's called. That would just sound horrible. You get sort of a whining or a squeaking or a screeching kind of sound for if like level or volume is sort of just moving in steps like that. So instead, within each window, it gets linearly interpolated from the value of that it was at in the previous window up to the value where it's at now. Actually, that's going to relate to another question, which was about wavetables. But to sum up, the resolution is it's window by window, and that can vary depending on CPU usage, but then it's often linearly interpolated between those. And let's talk about wavetables, which deal with some of those parameters which need to be linearly modulated. I'll just find the exact question. Sorry, where did it get to? What kind of interpolation is occurring when changing wavetable position in the synth? So yeah, not only is there interpolation there, but it ties right into the previous question. Seen a comment just now. from Alex, when you turn a gold encoder, what resolution is that value? That was actually that's in the list of questions to answer as well. Basically, the answer is the same as for Midi, 128. But hopefully, I'll get back to some more details on that a little bit later. Now, wavetable position or index, I sometimes call it in the code here. Probably actually should have renamed that since position is probably a more sensible word, and that's probably what most people will be referring to it as. So yeah, wavetables, as you'll know if you've used them, your position can sort of move between the start and end of the wavetable to get various kinds of sounds, and that will often be modulated with often an envelope or an LFO or anything else really. And that's actually not too bad if you don't interpolate it. Like in some cases, you wouldn't really notice the difference if it was just sort of stepping quickly from one position to another position, sort of window to window or something like that. So every few milliseconds or something. In some cases, that might sound okay, but it's not good enough. We do need to interpolate. This interpolation gets done linearly, and actually, so there's a couple of senses in which the word interpolation gets applied here. This gets confusing kind of quickly, but that's we're about to talk about the interpolation of the current position, so we can move to and fro just sort of very smoothly. But then there's also the interpolation from one wave cycle to the next. So let's not get them confused. There's of course, we only have sort of a fixed number of different single cycles within our wavetable, and we're going to interpolate between them. So if the position has moved along a little bit, then our sort of one wave will kind of start to morph a little bit into the next one, etc. So that's interpolation of the wave cycles. But now we're going to talk about how that position gets modulated between different positions that it could end up at according to parameter modulation. So yeah, basically, so this function here, we're in wavetable.cpp. This is the render function. Does what it says. This function gets passed a wavetable index. So that's index position, same thing. So that's where we are currently within the wavetable. Then wave index increment is that's sort of how far that needs to move along for the interpolation that's occurring per sample that we're going to render. How far do we need to move the wave position just slightly so that we get that interpolation within this window so that it's smooth? That gets pre-calculated. I actually had to follow the code trace back just before when I was getting ready to answer this question. And that gets set up in voice.cpp. Here it sets up the source wave index increments. Don't worry too much about why it's why. I suppose that name mostly makes sense. Source here, by the way, sort of means oscillator, basically. Yeah, that's what it means in this context. There are a few other places where interpolation like this is set up in the code. It's just sort of on a per parameter basis when it's needed for certain things like volume, yeah, things like that. Here it goes for each source or oscillator. It goes and sets it up by looking at the parameter final value now for that wave index or wave position, and then it looks at what that wave position was last time, so last window, so a few samples back, and then so it looks at how far we have to go, and then divides that by how many samples we're going to render, which might be sort of 10 or 20 or something, and then that gives us how much to increment it per individual sample. That sort of passes down the function call trail and ends up at this function that we were just talking about before, wavetable.cpp render. There's another this might sort of be a side point and not really what was being asked, but I'll quickly go into this because this was a bit of code that I thought worked nicely and solved a problem which could otherwise occur. If within our one window we're gonna fully switch from between two sort of single cycles all the way into being between the next two single cycles for the waveform and the wavetable, then different sort of lookup stuff would have to happen, and we don't want to be checking for that at every single sample. So what we actually do with the wave index increment is we actually see, we know how many samples are going to be rendering in this window, and we actually see if we're incrementing that wave index at this rate, are we going to hit that crossover point before the end of this window? If so, figure out exactly how far, then sort of do that bit of rendering, then sort of reconfigure for the next single cycle bit and do that for the next however many samples. So that's a bit of a complicated thing that all happens in here. Yeah, down here, this comment, see if rendering this window will span multiple cycles as wave index is incremented. Okay, that was just a side note of something I like nerding out about. But that covers interpolation, I think, in a fair bit of depth. Slightly related question: modulating sample start point. Is this limited? The person that asked this question essentially guessed correctly. Yes, it is limited largely, and a large part of the reason that this hasn't been implemented and would be a bit tricky, although totally doable to implement, is if it's not known in advance exactly what position that sample is going to start at, or if it's just not always the same, then we don't know what cluster of audio file data to store in memory. Of course, it'd be okay if we knew that the sample start point was always going to be within a certain cluster of file information. Then that would be fairly doable. But we wouldn't always know that if we gave the user the option to be able to modulate that to just wherever they want. Yes, we would have to buffer the entire audio sample in memory, which you could do. But there's just not a system in the code already for arbitrarily storing more clusters than just sort of the first two for an audio sample in memory. So you would need to make some system to do that. And yeah, clusters I talked about more in the codebase introduction document. Yeah, that's basically all I've got on that one. Oh yeah, and yes, clusters, just to briefly add on a couple of things. The system that sort of deals with caching them and storing them and deciding when to free them is pretty complex. It's detailed a little bit more in that document, but yeah, modifying that to do a whole extra sort of category of thing, like being able to store and retain them for an entire sample and make sure they don't get stolen, as it's called in the code base, by something else that wants to steal that memory. That adding that and getting that working consistently would be quite a project. Thanks, Fred, I think, for the comment. Yeah, it would be cool to be able to. I think it could be done. The idea of having the user sort of need to select and opt in to storing a sample in RAM. I like to think that it could be done a bit more sort of automatedly than that, like have the code decide whether that one needs to be stored in RAM according to whether any modulation has been set for its start point. Yeah, theoretically that should all be possible. Yeah, just quite a bit of work to set up. I think there was another wavetable question actually. Yeah, when you load a normal non-wavetable sample as a source for a wavetable oscillator, how is that approximation or interpolation done? Basically, it doesn't really do it. It doesn't do it nicely. This feature was not designed to work. It's just it won't stop you using any wave file you want for a wavetable. It'll use the file if you tell it to, but it won't do anything fancy or special to actually try and break up that sound. Like if you've sent in, say, the plucking of a guitar string or something, it won't go and detect the pitch and break it up into appropriate sort of cycles. It will just arbitrarily make cycles. I think it will just stick to the standard cycle size of 2048 samples that is usually found in wavetable audio files, and just slice up the audio file like that, just crudely. So you can try it. I mean, people have tried it, and sometimes you get cool sounds, but yeah, it doesn't do anything fancy or special. It's just crude. While we're talking about samples and wavetables, someone asked, how is pitch detected in samples? A very complicated system does that, which I spent way too long developing about 5 years ago. I got a bit obsessed with trying to make the best pitch detection algorithm that I could, because it was a big challenge. It wasn't obvious how to do it really well. So I spent a lot of time playing with this. This is in sample.cpp. And the function is determine pitch. I'll try not to talk through every line of code because there's a lot, but I skim read it again just before. Basically, it does an FFT on a window. It uses a Hanning window to capture just sort of like a few milliseconds or something of the audio. It does an FFT on that to see what frequencies are present. Some downsampling may happen, and we'll come back to that a little bit later. But it might compress things in, so it doesn't have to, so that it can, well, basically, a little bit further down, when it's determining the pitch, if it thinks the pitch is actually quite low, then it goes and condenses things down and basically uses a bigger Hanning window, or just sort of downsamples things first. But it does one pass first. It does an FFT of that. Oh, it even has some rudimentary audio start detection, which makes sure that it ignores any silence at the start, but it's very, very crude to do. Make it better. It hasn't quite happened yet. Then once it's done the FFT, and we've got sort of an array of values, which are how much audio content there is for that particular frequency, it goes through sort of looking for frequency peaks. So you'll recognize that concept if you've dealt with anything similar. I think it deletes or cuts off things that are below a certain threshold. So we're really just sort of looking for those peaks. It goes and finds all of those. Then it looks through each peak that it found and tries to decide whether that's just some harmonic or the actual fundamental root note that we're hearing. And the way that it decides that is, for each peak, it looks at whether there are more corresponding harmonics above that frequency that indicate that this would be not just a harmonic, but the actual root note. So for each one, it goes and calls this function. This is for each peak, does all of this, which is it investigate fundamental pitch, which I think it sends it goes in looking at just one peak, and then for that one peak, it goes in and looks at, I think, possibly all the higher peaks to see whether, examine harmonic. I think yeah, pretty much what I already said. I'm not going to try and re-decipher all of this code. But yeah, it decides if something is just a harmonic or the actual fundamental by looking at the higher harmonics and seeing what's there and if it matches up. What else? That was pretty much it. Yeah, if it decided the frequency was too low, let's get some better resolution by downsampling things and then having another go. And then it also interpolates if the peak that it decides was the root note was sort of halfway between two samples on the FFT, then it will interpolate between those. And it when it works very accurately, like to within less than 1 hertz if it's a reasonably low frequency. Okay, let's have a look at another question. Hope everyone's doing well out there. By the way, Ian and Jamie, got any questions or any extra comments along the way for the stuff that I've been talking about? Cool. I'll just keep going through some more of these questions. But yeah, anyone can chime in the chat, or Ian and Jamie as well if you've got any additional questions or thoughts or anything. Quick question here that I can answer quickly. How was the analog mode for delay achieved? It's a bit crude. It's not that amazing. I'm sorry. I opened up the file before. It's basically an impulse response that low passes and gives it some sort of grit. And then I think there's also saturation, probably tan-H saturation again. Which file was it? Impulse response processor.h. Yeah. This is what processes that impulse response, of course. It's the code is in the H file because it needs to be called as an inline function to make it as efficient as possible. So it just runs through this. The actual the impulse response itself is in, okay, that's in the corresponding CPP file. It's pretty short. It's only 30, I think it's like 31 values or something like that. And then I did also have the other file opened up. Well, maybe I didn't. Yeah, it's just tan impulse response and also some saturation. Pretty sure it's just tan-H. So yeah, pretty basic. Let's go for an even more complicated question, possibly the most complicated one on here, to do with caching for RAM, which is complicated. Someone was asking about this in terms of loading executable code as additional modules, which is great. Something I never attempted myself. And in terms of caching, it's usually when you're dealing with DMA that caching becomes an issue. This is done in several places in the Deluge source code. For those that don't know, DMA, or direct memory access, is when you set some process in the background, sort of still happening on the Renesas CPU, but it's a feature of the CPU that will be reading or writing to or from RAM on that chip in the background, sort of at the same time as your code is doing stuff to it. One example, probably the biggest example of this, is the way that the audio is output from the Deluge. The Deluge continually in software renders audio into its circular buffer, and then a DMA thread or unit in the background is continuously grabbing that audio data back out of out of the buffer and sending it out via I2S to the actual audio codec chip. And so the issue with cache, of course, is that if the Deluge was doing its audio rendering into that buffer, and if cache was enabled for that, then the main CPU core might think that it's written that data into the actual buffer in RAM, but it might still be sitting in the cache and not have been written out yet. And the DMA doesn't have access to the cache. It just looks at the actual physical RAM. So basically, yeah, there's plenty of cases where things can go wrong if you're needing to read or write to bits of RAM and you don't know if it's going to be cached or not. The way this is done for audio is relatively simple. For that, let's pull up this exact bit of code, if I can remember where it is. Okay, so we're here well within the drivers folder in the files relating to SSI, which is Renesas's term for I2S. SSI, I think, for them stands for Serial Sound Interface. The way that the Renesas chip, one of the ways that it sort of deals with cached versus not cached RAM, it has this mirror thing set up. If you look at the data sheet for the Renesas chip, which is very, very dense, of course, like all data sheets for CPU type stuff, it tells you about this. Basically, for most or all of the internal 3 megabytes, no, actually, this is even for the external 64 megabyte extra RAM IC. So any address on that chip has its address number, which is usually expressed in hexadecimal as a 32-bit number. There's also, if you look at this number here, sort of hex 40 million or 4 billion or something, if you add that and look at that much later in the sort of address space, it references the same RAM but sidesteps the cache. Which is very handy for something like rendering the audio. So when we need to write that audio data to RAM that's just been rendered to that circular buffer, we write it to that uncached mirror address. This is this is a preprocessor thing that I set up. Uncached mirror offset is this really big number here, some number of megabytes or something. So you can do that if you need to write to some RAM and or read from some RAM, and just know that cache isn't being taken into account. But this is only the first half of the story, because also if you have some code which is using the cache and some that isn't, you get equally big problems. But basically, for something like audio output, where especially it's that we don't need to be writing a whole lot of audio data to the output, or we're just going to be writing like a little bit at a time. So we don't mind sidestepping the cache, and if things take a little bit longer. And there's no other option anyway, really, because it's going to be often it's only rendering sort of a couple of samples, which is bytes or several bytes further ahead than is actually going straight out to the audio codec. So caching just isn't really an option anyway. We need to get that data right out there. Okay, but a more complicated case is for reading or writing data to or from the SD card, where that needs to happen via a DMA process in the background, but also we need to then access that data, and we need to do it fast. So we definitely don't want caching just switched right off for that section of memory or any such thing. Like we're going to be needing to stream audio data from the SD card into RAM. We want to do that fast and in the background with DMA. But then we need to be able to access that data really fast in the software using a cache sort of system for when we're partway through playing that sample. And we need to sort of combine those worlds cohesively so that nothing breaks. the person asking the question mentioned these particular functions, flash, cache flushing and write back functions. I'm actually not familiar with these exact function names. If those are sitting in the Renesas code base or Renesas drivers, then that's cool. I obviously didn't find them when I was originally developing the Deluge source code. The versions of these functions that I use are in invalidate.s, which is within source drivers, all CPUs, invalidate.s. Actually, that name should be something different, because invalidate is just one of the functions that's in here. There's also flushing. This is an assembly language file. Assembly language is not something I'm very good at or familiar with. So this is ARM. This code is from ARM. So these are the functions that I call. This is there is no header file for this. I probably should have made one, but this code is from a long time ago. The way that these functions are called, just find an example of where they get called. This is for the SD card. Yeah, so the sort of the header definition for that function, I pasted it into this file, which probably definitely is not the ideal way to be doing things. But this is if you paste these two lines or make a header file, then you're able to call these functions, which will flush or invalidate bits of RAM for you. Now, flushing is when your software, your program has made some data that it thinks is in RAM. So it's like written something to an array or something, and then we need to actually, and it will have ended up in a cache that the software doesn't really know about. And we need to flush that actually out to the physical RAM. So this flushing we're talking about here. We need to flush that out to the physical RAM so that something like a DMA process can read it. So yeah, that process is called flushing. This function takes a start address and an end address, and it will make sure that all the cache lines, as they're called, which is a small block of cache. In this case, it's on the Renesas processor, it's 32 bytes. I'm pretty sure there is a C preprocessor global thingy that I set up for that number of bytes. It's called cache line size. Anyway, this function makes sure that all the cache lines which overlap this range from the start to the end get flushed out, and then there's a corresponding one for invalidate, which is invalidate means for when you need to reread some RAM that's ended up in the physical RAM by some other process like DMA. So when the SD card, when our DMA process has got some data from the SD card and put it in RAM, in order to access that data in software, we need to invalidate any cache referring to that RAM. Say like, this cache isn't valid anymore, throw it away. We just need to actually read that actual RAM, bring it into a new cache if need be, and then we can deal with it. The person asking this question, I think, talked about getting freezes and stuff. I don't think I've ever had. I haven't specifically got freezes. Hopefully, actually, maybe freezes are just relating to something in those particular functions that the person referenced that I'm not familiar with. So maybe if you try calling these two functions instead, hopefully that might work a little bit better. But there are many caveats and complications to dealing with cache. It's fraught. You'll have to try a lot of things, and still sometimes it might seem to break. Whereabouts in the code would this be? There are places where I had to do a complicated thing. Like in some cases, it seemed you needed to. I can't remember if it was flush or invalidate, but it seemed I had to do one of them like before and after the read or the write, whichever one it was. And then there's also issues of overlapping stuff in memory. So for instance, if you have sort of some bits of data that overlap and exist within the same cache line, if you go in and validate something that's on that overlaps that cache line, then you've also gone in and validated and thrown away any data that you've written into your array that touches the other edge of that cache line. So all sorts of things can go wrong there. One solution to that exact issue is to make sure that whatever particular arrays are spaced out by more than the cache line size, which is 32 bytes. But even then, sometimes you just run into issues. So definitely good luck with that one. But yeah, it's something you can get to grips with and make it work really nicely. All right, more questions. This is a fairly simple one to answer. The requirement to have the Deluge plugged into a DC power source to function as a USB host, is that a hardware limitation? Yes, but the limitation is not as bad as you might think. That requirement is just for the Deluge to be able to power the connected USB device. So if you're connecting the Deluge to a USB Midi device that has its own power, then you're actually not bound by this restriction at all. Like if I wanted to plug it into right in front of me here is an Arturia key step. I could do that just fine if I was powering that externally. That could then the Deluge could host that via USB without the Deluge being connected to 9-volt DC power. But yeah, I suppose the caveat is that something needs to be getting external power in the situation. But yeah, and that is a hardware limitation. The Deluge cannot output 5-volt USB power unless it's getting like 9 or 12-volt DC input power. It can't physically, but sometimes you might not need that 5-volt USB output. Yeah, if your device has its own power. Okay, more questions. There are plenty of other good ones in here. Let me just see what I've skipped over. Feel free to chime in, anyone, Ian or Jamie or anyone in the chat. Looks like we're making pretty good headway on these.
Cool.
Okay, the undo chain. What will make it break or reset or clear? So users of the Deluge will know that, of course, you can hit the back button to undo. The most recent thing, you can undo multiple steps, but there are some cases where you do something or go somewhere and then you can't undo any further. Basically that gets cleared anytime you do something that doesn't have an undo implementation on the Deluge, and this happens sort of manually. So let's go into actionlogger.cpp. So yeah, action logger and actions. That's the terminology that I've used here for dealing with actions that can be undone. So the action logger logs the various actions you've done, and then can sort of step back or forward through them. Maybe that's worth actually quickly going into a little bit more depth on. Actions, pretty much there's only so there's action. Let's go into the header file for that. There's only multiple types of action. I can't quite remember. No, actually, it doesn't even have any subclasses. So basically, an action is for each thing you do. Like you might sort of add a note, or I think even muting clips has an action that's undoable now. I think there were definitely a lot more have been added since we first implemented undoing and redoing, which also gets referred to as reverting in the code. But okay, and this seems we store them as a linked list, which is, I used to use them for a lot of things, not so much now, but for a case like this where you only do need to sort of step through them one at a time, it's not completely unfitting. Now, within each action, which usually represents one thing the user might have done, adding a note or changing a parameter to just sort of once, because if you do multiple quick, well, it doesn't record each individual sort of click of the knob as one action. It combines them, but basically, yeah. So there's an action object for each action that you've done, and then within them are multiple consequences. So this is all just in terms of undoing and redoing things. None of these classes, none of this code, or almost none of it, has anything to do with just as you're doing things on the Deluge and how the actual events unfold as you make your song or anything. This code isn't relevant to it, but it stores the stuff so that when you undo and redo things, it knows how to get back to and from. Consequences, you will have noticed these. I probably should have made them their own folder within the code base. There are all these different kinds of consequences, which are literally consequences of your actions. Like, for instance, if you what's a more complicated one? If you've been using the live looping feature, and that has repeatedly done things like beginning playback, creating a clip, various sorts of things like this. Sometimes those things can happen sort of within one action, like you hit the foot switch or whatever you're using, and it begins playback and creates a new clip. So those would exist within the action, the same action. Now, each of these consequences has a revert function, which can revert either forwards or backwards in time, or just, basically, let's say either forwards or backwards. So the various different kinds, like the consequence begin playback, its revert function is really easy. It gets past the argument name is time, and it can either be before or after. These are just preprocessor numbers. So if we want to revert our beginning of playback, then if we're going back to before, then we just simply switch off playback, or if we're going back to after, it starts playback again. This is probably one of the more rare things that you might want to undo or redo, but because only a couple of actions actually, I think if you just hit the play button to start or stop playback, it doesn't bother with one of these. This is for if it happens as part of the looping process, really. But maybe a slightly more normal one would be clip length. And so its revert function, this one looks a little bit more complicated because it doesn't distinctly talk about before and after. But it ultimately calls the set clip length function, which exists in Song for complicated reasons, but there you go. Anyway, back to the original question, which was, how is it determined when that whole undo chain has to be cut off when you've done something that's not undoable? So actionlogger.cpp, there is a function here, delete all logs. Now this gets called from many places in the code base, and it has to be called manually. So I had to decide where to put this in the code base for when the user does something that they can't undo back past. Like I think it's still that if you go into the sound editor, it deletes all the logs, because things within the sound editor, there's no implementation for undoing changes you do within the sound editor. There could be, but that's just not implemented. And there'd be maybe some complicated questions there if you were to implement that, like if you've changed one parameter, then you go navigate to another one. But if you undo, should it take you back to the first parameter? And just that sort of thing. That's one of the reasons that's not implemented at the moment. Yeah, if we do a search for all the places that call delete all logs, here's the search window. So there's 40 places that call it, including one, as I just mentioned, in sound editor setup. So when we're entering the sound editor, one of the things that happens is it goes delete all logs. Can't quite remember what the case is where it doesn't. Oh, I think, yeah. The only time that it doesn't do that is if it's failed to actually find, or if it hasn't let you go into sound editor for some reason, then it won't go and delete the logs, but normally it will. Other things like, what's this? In keyboard screen, if they hit the scale mode button, there's no implementation for undoing a change to scale or to being in scale mode versus not. So again, delete all logs gets called, and the user loses all ability to step backwards or forwards. I think that covers that. All right, we're getting through these questions. I thought I was taking a long time up answering each one, but maybe I should talk even slower or go into more detail or something.
You don't have to drag this out.
all right, I'll keep it quick then. This one. For the goal encoders, there doesn't seem to be a way for those to act in a bipolar way when controlling bipolar modulation parameters. Is this a limitation in the hardware or the firmware architecture? Yeah, it's definitely not a hardware limitation. It's a firmware architecture one. I think some parameters, I think possibly most of what I call parameters, but I'll come back in a minute to what the other option is. I think all of the actual parameters are modulatable bidirectionally. Like for instance, pitch. If you set a gold knob to control pitch, you can go both up and down. But what is sort of singular direction, or will only let you put it positive rather than negative, is modulation depths. For instance, vibrato is one of those. Well, it's probably the most common modulation depth you might have edited without realizing you were editing it, because vibrato we just think of as vibrato, but it's actually an LFO patch to pitch. And there is standardly a gold knob controlling that. But that's probably a bad example because it would sound just the same if you flipped it upside down. Well, at least if it was a triangle or sine wave. But if you were doing something else, like if you had a gold knob controlling the depth of envelope modulation to pitch or to filter frequency or anything, sometimes you might want to flip that upside down. And yes, the gold knob implementation won't let you do that. You have to go into the sound editor. It's purely a hardware thing. And I guess the reason I made it that way was that, yeah, in many cases, you don't need to, or it will be a less common thing for someone to want to do. And we're dealing with sort of real estate of really just the indicator level next to each knob. If we make it bidirectional, then we have to be able to, well, first of all, the user might, if they want to turn something off, they might want to just flick the knob anti-clockwise as far as they can, and if that suddenly modulates things negative, it's that bit harder to find your way back to zero. And then also, yeah, using the indicators next to it, next to the knob, to go all the way from, if sort of halfway up is our 0 point, then we only get half the real estate to go up and down. Although I'm just thinking now, I suppose it could be done that I suppose an idea that a way it could be implemented is, I suppose the level could go from sort of up all the way down for positive values, and then for negative ones, it could actually start growing from the top again. That's just an idea, but basically, yeah, definitely a software limitation, and other implementations could be done. I've already answered some of this question, but let's just go into it in a little bit more detail. What are the technical details behind how modulation and MIDI CC data are stored in a clip? So that's these param managers that we talked about before, but I'll go into just a little bit more detail on that since someone would clearly like to know about it, and it's an important part of how a lot of stuff in the Deluge works. So yeah, param manager. Within that, we've got don't worry too much about these summary objects. Sorry, okay, this code is a little bit dense. Okay, it's even more dense than I remembered today. I'll just talk through some aspects of it. So yeah, param manager stores several param collections. I won't go on about this for too long since we already talked about this a little bit, but yeah, param collections. So a param manager will have up to several param collections. So these are for different types of parameters. For instance, Midi param collection, since the person was asking about Midi specifically. So Midi param collection stores all the Midi CCs for that clip, basically, and their automation. I think MPE is separate because that's per note row anyway. I think that's its own separate param collection. I have to come back to that. But anyway, so param collections have sort of obvious functions like delete all the parameters, set play position. So this is for we're talking about Midi in this case. If you've got a Midi clip on the Deluge and play position is suddenly being reset to a certain point, for instance, I suppose that'd be if you've scrolled along and then you're holding down the horizontal encoder and press play, it will start playing from a particular position. There's some other cases where the play position can get reset as well. This will step through all the different Midi parameters, which in this case are mostly CCs, in this param collection of that param manager of that clip, and set the play pause for each param individually. And within each param, so auto param is what it's called because it's automatable, and they store lists of nodes, which are sort of if automation has been stored, if you've recorded it straight from a knob, it'll sort of be connected and curvy, as opposed to stepped, which is more what you get if you've held down a pad and turned a knob to make sort of stepped automation like that. Basically, set play pause looks at that list of nodes along the way and decides which one we're at right now. So yeah, auto param, definitely have a look at auto param if you're interested in param automation, of course, because there's quite a lot of code here for accessing, recording, editing parameter automation. And yeah, one auto param exists for each Midi CC for the ones that have been set up and utilized, and for each parameter of the parameters that we talked about much earlier here in definitions.h, all these different parameters where we talked about the different exponential and linear ones. Each of these will have an auto param, usually per clip. But if we're in a kit and there's a different sound or different drum per note row, then each note row will have an auto param for each of these. Quickly to elaborate at that one a little bit more. So that was the Midi param collection. There are other types as well, like, sorry, I'll just refer back to the question, see exactly what the person wanted to know about. Okay, modulation in general. For regular params, there's yeah, patched param set. This is the most normal sort of parameters. Again, that kind that we just talked about that are in definitions.h. These are all patched params because you can patch or you can modulate them with modulation sources. So these are all the patched params. We won't touch on this too much for now, but there are also unpatched params down here, ones that you can't modulate, like bass and treble amounts, bit crushing amount. Someone could implement that. For most of them, it would be doable. So yeah, there's also another type of param collection. So we just talked about the MIDI one. Now there's also patched param set. Param set, param collection. They sort of refer to two slightly different things here, but of course the choice of language there is I don't know, maybe not the most descriptive, but yeah, patched param set has specific functions for if one of its parameters gets modified by some automation or something, it has to be able to talk back to the sound and tell it that its parameter has changed and that it needs to recalculate something or re-render something. There's also patch cable set. So this stores the modulation amounts, like for an actual sort of source parameter pairing, like the vibrato amount or the amount that an envelope is patched to pitch or something like that. So each of those sort of pairings is called a patch cable, and this is the patch cable set. It stores all of those for a particular clip usually, but could be a note row if it's a kit. And these all have functions like to tick along a certain number of samples in time or actually it's a bit more complicated than that. That's for if some interpolation of values is happening as opposed to we also can jump to a certain position or process current position. All right, I think that's probably all the detail for that one that I can really go into without going into way more detail, which is probably a thing for another day. But yeah, parameter automation. What else have we got? When MIDI data is received by the Deluge, is that data smoothed or interpolated in any way? Basically not. The person also asks, what about MIDI data sent from the Deluge to another device? Basically, it's not interpolated. Actually, way back a long time ago, like maybe 5 years or more, originally MIDI CCs sort of did get interpolated because that was just how the code was in the first place. And I can see now that that's definitely not a good idea. So we did make a change there at some point where it now will replay basically the exact MIDI CC messages that were recorded into the Deluge. It will play back those exact numbers. And if some of those numbers are skipped, it'll skip them as well. Whereas previously it did an interpolation thing, which annoyed some people, and I can see why that was. That definitely shouldn't have been that way. I'm just trying to think. I think the same applies to pitch bend as well. Can't quite remember if there might. At some point there was modulation on that as well. Hopefully not anymore, because there probably shouldn't be. And yeah, nor is there any interpolation for MIDI going out of the Deluge. Yeah, including things for like MPE. It does store those individual actual values that were recorded in and sends them back out. Actually, maybe one slight caveat to all of that is that the time resolution on the Deluge, which standardly is, I think it's 192 ticks per quarter note or something. That's down to 64th notes and then 3 sort of like a triplet within each of those. So basically, if it did receive multiple MIDI CCs on the same parameter within that time span, then it would only store one of them. So that's actually a case where data could get skipped theoretically, but it would have to be sent through in very quick succession. But yeah, no interpolation. I'm 99% sure. I'd have to well, I invite everyone to have a look through the code. That would all be again in Midi param collection. That's where you would look to see if there was any kind of interpolation, and also just how Midi actually gets read from the auto param objects which store the implementation. Here's actually here's just what I was referring to just before. For Midi CCs prior to firmware version 2.0, which I think was 2018 or so, prior to that, it did do interpolation. So now if we are loading project files, song files from before version 2.0, it actually has to call this function and sort of de-interpolate the Midi data. That's right, because yeah, it also could sort of what's the word? If you sent in a quick succession of Midi CC values and it could see that they were linear, it would go and just store it as one linear run and then sort of re-interpolate it on the way back out, which, yeah, that was a bad idea. Hasn't done that for a long time. But if it does go and load one of those project files that essentially had some data sort of chopped out because it knew it could be re-implemented, re-interpolated, yeah, anyway, this code gets makes that all sort of standard so it can work fine now. Now there was actually another really interesting question that I just remembered I should definitely get to. How does the session and or playback handler achieve scheduling things to happen in the future, specifically clip launching and launching sections? And the person asks, what should I be aware of if I want to schedule a clip to start at some particular point in time? So the way that scheduling of things happening at particular times happens, and yeah, this is mostly relating to launching a clip. If we go into session, or actually I opened up these files before. So session song view is sort of called session in-house. In the code, it's called session. There's a session view .cpp is song view, and then just session .cpp or .h, where did it go? That refers sort of the inner workings of session style playback. Go. So the way that it keeps track of and decides whether to launch a clip at some particular point in time, repeatedly, this function here gets called consider launch event. This gets called each, you could almost say at each clock tick, but for efficiency, it skips clock ticks at which nothing happens. These are often referred to in the code as swung ticks. In fact, that's what it's usually referred to, because they are ticks which have already had swing applied to them. So the swing feature on the Deluge, when you turn that on, of course, it makes a swing rhythm where some things occur a little bit usually later in time than they otherwise would. So swung ticks, what the playback system sort of usually deals with, and that's sort of post the swing implementation. Don't worry too much about that. Let's just say we're always dealing with swung ticks, and let's just call them that. So regularly, this function here gets called each time something's going to happen, and we'll continually reassess when the next thing is going to happen. But we come back to this each time something will happen, which could actually just be the launch event itself, or there might be other things like playing notes happening at a certain time. We get here and what do? We check if there is a launch event right now. So we will have actually stored, if someone has set a clip to launch, like by pressing its button or something, we will have stored in this variable the time at which it's meant to launch, or the swung tick count, because we're moving along tick by tick, and we've got a running count of where we are at right now. And that's swung tick count, by the way. That's not per clip. Of course, each clip does have its own current position count, but this is sort of since playback started, a swung tick count. So for launch events and things which the user might keep sort of triggering at any point in time, we refer to that point in time by talking about how many ticks have actually passed since playback began. So yeah, we basically we check that there is some launch event scheduled, and then we check the swung tick that we're actioning right now, because this whole function got called as part of a swung tick, and as part of this all being called, this variable here has already been incremented. Last swung tick actioned, which is the one being actioned right now. We check if that has reached that swung tick count at which we need to do the launch event. If so, we consider in any repeats that need to happen. If the user has used that feature, we can turn the select knob and make it so we're waiting a couple more times around, or loops or repeats until the launch needs to happen. Once that's done, couple of special cases, a special case for if we're doing a song swap, like if we load in another song and that's going to start playing sort of at the end of the current loop, and then we do that here. Or if we're switching from session or song mode, song view, I call it session and session view in-house. That possibly should have called it that originally. But yeah, there's a feature that lets you switch to arrangement-based view, playback from session. So yeah, this is just another thing that gets taken care of there, or probably definitely the most common case, which is for if you're launching clips. And that happens within this do launch function, which actually has a whole lot of complicated logic. It's not the most pretty function, but this does all sorts of things in terms of launching clips, stopping clips that were scheduled to stop at the same time, and then also making, if one clip launches and another clip was already playing with the same instrument, which could be synth, kit, MIDI channel, etc., it has to make sure the other clip gets muted, and various other things to do with recording, like looping as well. It gets dealt with in this function, which is do launch. What else can I say about that? If people are wondering how we actually get to how we decide where to put what number to put, or where we decide what swung tick count we should launch that event at. Let's just have a quick search. It's a while since I've dealt with this bit of code as well, but that's right. Oh, okay. There's a function here that can help with that. For setting up that launching. So yeah, session : schedule launch timing. You pass it what swung tick count you want to do the launch at, and it sets up some other stuff. In terms of how we decide that swung tick count, well, that goes a little bit further up the call tree, and there are many different cases for this, like arming for a song swap, which we talked about just before. Could even be that during a do launch, which I talked about that function just a moment ago, and there we might decide we want to schedule some more clips to launch. If, what's the condition there? Some clips are still active. I think this is to do with recording. No, that's to do with, I think it's if all clips stop, then it re-enables the first one, or maybe not. Yeah, I think it's sort of a fringe case. Some other functions you could have a look at. Yeah, there are many functions here in session.cpp. There's a whole block of functions that deal with what happens when you actually when the user presses a launch pad on a mute or launch pad, and how that sets up, how it decides what to do and how it schedules that. So I think this is possibly the first function that gets called there. Arm clips to start or solo with quantization. Quantization being just that it doesn't start playing immediately, it arms it to launch soon. So yeah, have a look at that function. I think that just gets called. That gets called with another function further back up, which is user wants to arm clips to start or solo. So have a look at that, and then yeah, that sort of passes down the call tree, and then it ultimately gets to that function below that was sort of schedule whatever it was. I think that's probably enough detail of that for now. What's up, Ian?
Oh, I zoned out for a little while there. Did you answer that question that's in the YouTube chat? Because
I was actually just reading that just now.
Okay, cool.
So it seems that even muted kit samples take up resources, leading to dropouts. A larger kit is loaded. Yeah, this is an interesting one to talk about. Generally, I like to say that the performance hit is not too bad. It's definitely a lot better than it used to be. In fact, well, in some cases, I think at one point I said it was now non-existent. I think I then slightly walked that back and realized there were still some cases where it caused a slight performance overhead. In terms of samples being loaded or needing to be sort of cached or buffered from file, I think if there's a kit, and if the kit has rows for that sample or whatever, I think it does have to be constantly in memory. Well, at least like 2 clusters of that file have to be in memory, which isn't too bad because we've got 64 megabytes of that external RAM chip, and each cluster is only, well, it really depends, often about 32 kilobytes, or could be much less. So yeah, there's a little bit of a RAM overhead. In terms of CPU, that's it is very minimal now. I'm just trying to think. I think yeah, it's a little while since I've dealt with this bit of code. I think if a row in a kit is muted, I think it possibly completely skips the rendering code for that sound if the row is muted and if there's not a voice currently playing for that. I think let's just quickly pull up that bit of code. I think no, it's in kit.cpp. I think it actually maintains a list of what sounds within the kit actually are active or might still need to sound because they're unmuted or because there's a sound still playing, or which of those. Let's see. I think it maintains a list, and then it doesn't even think about the other ones, or doesn't even cycle through them. Where are we? Yeah, drums with rendering active. So that is a list which gets maintained. And so this is the audio rendering code for kit. Global Effectable is a curiously named superclass or parent class of kit. Don't worry about that too much. This is the rendering function for kit for rendering audio, and yeah, it only thinks about the drums. Drum just means sort of sound for a row. It only thinks about the ones of those which are actually active. Actually, I think this even skips ones that just don't have a sound playing right now, like just happen not to have a voice sounding right now. Even if there are other notes on that row, it will just completely skip over those. But some other things do have to get thought about a bit more often. Like, for instance, when position gets ticked along. Generally, all clips and note rows, well, at least how the code used to be, definitely all clips and note rows would get that instruction to move ahead a little bit. So if there were note rows that within a kit, and of course some people very reasonably were loading kits for hundreds of samples, because why wouldn't you? But there originally was that sort of performance limitation where then each row would have to sort of position itself all the time. But now, yeah, different function. What function would that be? Confusing myself a little bit. It does mostly skip over that stuff now. Here is the function clip process current pause. So this is anytime we've sort of ticked playback forward by however much it's predetermined it is until the next event, like the next note on or note off or anything. Each time it's time to think about the next bit, because we've got there, each clip gets this called process current pause. That reminds me, must come back to the question about relating to reversed and ping pong and random playing. Someone asked that. I definitely will answer that next. That's right. This is some complex code here. I'll probably come back to that in terms of that question about because yeah, reverse and ping pong, super complicated. There's just all sorts of special cases, and there's a whole bunch of code there. But just trying to work out where's the bit that just deals with general ticking forward of note rows. Sort of expected this function to be longer. Where's the main bit? Where's the actual code that's doing the stuff? Here it calls it on the param manager, saying process, telling it to process the new position. Somewhere it's got to be. Oh, I know where it is, because this is just the process current pause function for clip, but that's just for all clips. And there's different types of clip, because there's audio clip and also instrument clip, which is the one with the note rows. So that's it. This is it's not a virtual function, but it gets called in conjunction. Maybe one calls the other within wrong file. Within instrument clip. I'll just quickly go over this. So yeah, here's what we're looking for: instrument clip process current pause. So this does go through all the note rows. Okay, so it does tick all the note rows forward. Okay, so there's a little bit of a performance overhead there. And that's, I think, even if the note row is muted, yeah, it doesn't check for that. Can't remember right now why not. And then yeah, it gets into note row process current pause. Just trying to think. There is some bit here where it gets out early if nothing's happening. Here's where, if it's muted, it gets out-ish. I swear there's some code so that at least if it knows that there's no event for a while or ever, or if it's muted, it doesn't do anything further. But that is a little bit deeper into the code than I'm able to get right now. So quickly back to the original question. Yeah, there's some slight performance overhead when lots of samples loaded in a kit, but not as bad as it was, and it's not too bad really. You have to have quite a lot loaded before things get really bad, but I appreciate that it definitely is always improvable. Just having a look at the questions in the feed. Longer samples are playing. Do they eventually get loaded into RAM completely? Short answer, no. Long answer, maybe. More details on this are in the codebase introduction document that I wrote. Yes, exactly. It would fall back into just the first two segments being retained in RAM, but it will leave the whole thing stored or cached in RAM until something else needs that RAM. So if you don't have much else going on, the whole thing might end up in RAM, and it might end up staying there and not needing to be reloaded from disk, from card, I mean. But yeah, also that memory is available to be stolen by something else that needs that memory. I'll come back to the question in the feed in a moment, but I said I was going to answer next the one about someone says, I'm interested in creating alternative play directions for note rows, specifically a random step mode. Any tips or concerns relating to how you might implement that? In a similar way to ping-ponging or reversing. Yeah, it definitely could be done, of course. Anything can be done. Some relevant concerns. We're in the right function right here. So note row process current pause. One thing, and I talked briefly before about how functions like this, the process current pause function, will only get called when an event is actually happening, and we determined sort of at the last event what the next one is. By the way, that all gets reset if something happens, like the user adds a note in the sequence. That then calls for a reevaluation of everything. But if nothing's changed like that, then we would have determined at the last note how long it is until the next one, and then it won't get thought about again until then. So one possible limitation with a random position thing is to elaborate a little bit more on what I just said. So this function, process current pause, actually returns how many ticks until the next event, and I think the same is true for the process current pause function for clip as well. So this is how we actually know how long it is until we need to come back to this function or to all the process current pause functions, because it's even if the event is only going to happen in one place, it does just call all of them or almost all of them, I think, for simplicity, really. So if you were going to have it randomly jumping to a different step, yeah, you might want to determine ahead of time or calculate that randomness ahead of time, so you know when it's in this function, you know what step it's going to jump to and whether there is a note on that step. Because if not, then nothing's going to occur on that step potentially. So you wouldn't want to come back to this function, although it wouldn't be the end of the world if you did. Another thing I'm just thinking in terms of implementing a random step kind of feature. Yeah, you'd need to probably with this function, you'd need to make sure that it does return here at the start of each step, however you've defined your steps, whether it's the current zoom level or if it's locked at 8th notes or 16th notes or whatever. This function would probably need to know that and probably need to tell it or return a value that makes execution return here at that note boundary, because otherwise if there is no other note in the sequence anywhere else at that boundary, it might just sort of skip it and not come back here at all. Yeah, it's really just those couple of things, knowing to to make sure that that an event happens at the right time, so that we can go and move to a new random position and do something if there's a note there at the new position. And yeah, maybe it was just that thing. Yeah, in terms of ping-ponging and reversing as well, probably a lot of this code wouldn't really be too relevant for that. A lot of the complication for ping-ponging and reversing is that if things are reversed, then we have to think about the end of the note instead of the start of the note, because we're going to hit the end first before we go backwards, and then hit the start. Whereas for random, that wouldn't so much be a thing. Yeah, so a lot of this logic wouldn't really apply. So yeah, I don't think there's anything else I would particularly look out for. Just looking at questions in the feed. Magic numbers. This is the way I've implemented sort of fixed point numbers. The reason for those exact magic numbers is that they are a power of 2. Arguably, or definitely, I probably could have made this code make a bit more sense and be more readable. But yeah, usually when those numbers are used, it's using an integer as sort of a fixed point number, and the example there of 16 million and something, I think that's 2 to the power of 24. And actually, yeah, for a lot of parameters, that's sort of the internal value that the Deluge uses for pitch and time stretching, where it deals where the code internally has to know, well, it has to know how much pitch bending or shifting we're doing, or how much time stretching. That number 16 million is often used for the sort of 0 amount, or the not adjusted amount, and then if pitch doubles, that number doubles, and vice versa. That number was chosen so that there was enough headroom to sort of go up and not overflow beyond 32 bits. So it can go up. We can get, so we've got a spare 8 bits, so we could get sort of like 256 times higher, or maybe just 128 because it's a signed number. Usually that gets dealt with in the code, but also that it is a big enough number that it gives enough fine detail that we're not getting here any stepping or any such thing when we're shifting between values. Phase increment specifically, and that number there, 20 or 2.1 billion, I think. Phase increment that's a specific thing for oscillators. It's sort of the phase increment, yeah. So the actual current phase position of an oscillator, I think often that variable is just called phase, or maybe osc-pos. That's where we're at within the oscillator cycle, and that is stored as a full 32-bit number between 0 and 4 billion and something. The reason it's done that way is so that we can add the phase increment to it, and it will overflow if needed, but we can just sort of get straight to the next oscillator position for that next sample that we're rendering. A really easy way. This is a standard way that it's done in digital synthesis. You just increment that phase by a certain amount, and you don't have to worry about it wrapping back around to 0, because it will just do it. You don't need to worry about when you've hit sort of 360 degrees or whatever of your sine wave or whatever. It will just automatically go back to the start without any inefficient extra code. Yeah, that particular number there in the comment, that 2 billion and something, I know that is the maximum number that you can store in a signed 32-bit integer, and that's 2 to the power of 31 minus 1. Yeah, in terms of what that exact line of code was doing, I can't remember right now, but yeah, hopefully that gives a vague idea of what's going on there. I think that's actually most of the questions. And we have reached our end time. Actually, one really quick little one I've got at the bottom of the list here. Someone asks CPU usage between 12 dB and 24 dB filters. I was actually interested by this one because if the person asking meant that they're actually seeing better CPU usage from the 24 dB filter, that's the opposite to how it should be. That takes up more CPU. If that's really what's happening, then that's a bit of a weird mystery. Basically, yeah, looking at how many voices are being culled is a good way to estimate CPU usage. And yeah, if there are if more voices are remaining, so if we've got more voices still playing after some have been culled, then that means that CPU usage is lighter and vice versa. So it should be that when you switch to the 24 dB, you should be able to get less voices still playing because some would have to be cut out because CPU usage is higher. So if that should all work fine, but if that is actually back to front for some reason, then I don't have an explanation for that right now. All right, Ian, I think that's pretty much everything.
Cool. Yeah. As I introduced at the start of the show, this has gone wild and way faster than we could have imagined, and there's definitely a lot of questions out there floating around between connections between the community at large and the coders and what's going on and how to make everything work and what's happening with all of that sort of stuff. So just everyone relax and we'll have some details out there soon. And yeah, thanks again for Rohan for doing this. I don't know if we'll do another one of these in the future. I mean, I think there's a lot of information out here in these two videos. We've got Aria and Jamie on the GitHub. So if you've got questions about the code, feel free to hit them up direct. If there's something that only Rohan can answer, I'm sure he can like jump into the GitHub every now and then as well and chime in. Yeah, have fun with the code and don't break it. And yeah.